In this lesson, we will learn how to name and write formulas for the type 1 ionic compounds, that is, ions that begin with a fixed charge cation, one from your ion sheet. The naming is, if you know your ions, naming is one of the easiest things that you can do. You start by writing the name of the cation first, must be the positive guy first, and you write the name of the anion second. If you like, you can think of, ladies first. You think girls are good, positive, and ladies first, if you like. And then bad boys go second, whatever. Cation first, anion second. And the third step is, there's no other step, that's it. It's very simple. As an example, to write the name for, what's going on, there we go. To write the name for a type 1 ionic compound, let's deal with something where we're given CaF2. So we look at that and we say, we quickly identify that Ca is calcium. It is calcium, it's on our ion sheet. That's a type 1. So we simply write, I'll do it down here, we write calcium. And the ion, the anion, the second part, the negative part comes second. And that is, we don't worry about the 2 yet. We'll see where that comes from later. We just know the name of that ion is fluoride. Calcium fluoride. And that is all. That's all there is to it. If you're naming, it's one of the naming type 1s is one of the easiest things that we got. Let's do a different one real quick. Let's say that we have LiNO3. We say, well, that first ion, the cation, is lithium. So we write lithium. And the anion name is nitrate. My board's a little disoriented here. Nitrate. Now that's kind of important. For these type 1s, it's just going to be one cation and one anion. If there's more than one element in there, you're going to have to recognize that combination of elements as an ion with one name. That's one of the reasons we spend so much time learning our ions, is just so that we can recognize things like this. Lithium nitrate is what we want to say. It's not lithium, nitrogen, oxygen. It's nothing like that. It's lithium nitrate. You're responsible for recognizing that and knowing that that's what that is. So that's how you write names for type 1s. Well, what about whenever we need to write a formula? Writing the formula is a little bit more complicated, but you can still do it with ease. We're going to start by writing the symbol, of course, with the charge. Now the charge will not be part of the final answer, but you're going to need the charge in order to do it. Write the symbol and the charge of the cation first, of course, just like before, and then this symbol and charge of the anion second. What we're going to do next is we're going to give subscripts. Those are those little tiny things below and to the right, like in H2O. 2 is a subscript. We don't want H2O in our notes here, but it's just showing you what a subscript is. That 2 is a subscript. Give subscripts to any ion as necessary to make the total charges even, cancel out. And so we'll do a couple of examples here. First of all, let's so now we're taking a name and turning it into a formula. So the name, we'll start with a name of a type 1 here. Let's go with potassium arsenate. And this is, the board is acting particularly weird right now. Potassium arsenate, we're given that name, and we have to write a formula for it. So we simply look at potassium and we say, well, what is its symbol and its charge? Well, its symbol and its charge is K+1. And then arsenate is A SO4, its charge is -3. Now again, these charges are not going to be part of the final answer, but we need them to write the final answer. So we have this charge from arsenate, and we have this charge, this +1 from potassium. Whenever we're done, what we're going to need is a certain number of potassiums and a certain number of arsenates such that their charges add up to 0. They got to balance out. So we have +1 and -3. Well, obviously those do not add up to 0. So what if we had another +1? If we had another +1, then we would be a little bit closer. Now we have +1 and +1 is +2. That does not cancel out -3. So let's try a third potassium, and now we have 1 and 1 and 1. -3 does equal 0. So those 3 +1s, when added together, plus the -3, do equal 0. So what we found is that we actually need 3 potassiums and 1 arsenate. And so the way we show that is that we show that there is a subscript of 3 on the potassium, and that we only have 1 arsenate. When we're done, we don't need any charges because the charges have already balanced each other out, and that is one example. Let's do another one real quickly. What about magnesium arsenide? Magnesium arsenide. So we're going to look at the charges. Magnesium is Mg. It's got a +2 charge. I'm sorry, my computer is it's lagging. It can't keep up with my writing. I'm trying to write very slowly. So the magnesium is +2. The arsenide is As. You can get these off of our ion sheet if you're not sure where these are coming from. That's alright, we learned our ions, we don't need to look at them. And so, kind of like when we were doing those ionic Lewis structures, it's kind of a puzzle. How many of each do you need? Well, if you have +2 and -3, well, we have too many negatives, so let's give it another positive. But we have another positive. Now we're +4, -3. Now we're 2 positives, so we give it another negative. Now we're 2 negative, -6 on the right and +4 on the left. So if we give it another positive, we can see that it takes 3 of these. 3 + 2s is +6. 2 -3s is -6, and so it took 3 of these and 2 of those. And so we can show that in terms of chemical formula with our subscripts. Magnesium, Mg, 3, and As, 2. Mg3, As2 is our answer. Now finally, the last examples deal with polyatomics. Polyatomics ions with more than one atom in them, such as nitrate and arsenate and hexafluorosilicate and tartrate. These must be grouped together into a parenthesis before subscripts are added. And I'll show you a couple of examples of what we mean here. Let's take the example of need a new page. Let's take the example of calcium hydroxide. Calcium hydroxide, we want to write a chemical formula for it. And so we look up the symbol in charge of calcium. It's Ca + 2. Symbol in charge of hydroxide is OH - 1. And we're probably getting kind of good at this point. We realize that we're going to need 2 of these and 1 of those. And so we're going to write that, Ca 1. Now you don't actually use a subscript for 1, you just kind of have the assumed 1. And then you have OH. and we want 2 of those. Now if you just put a 2 here, that is not 2 hydroxide ions. That is an O with 2 H's. That's water. You don't want that. You don't want water, you want 2 of these. You want 2 of those. You want 2 hydroxides. You want 2 H's and 2 O's. So what we got to do is put a parenthesis around the whole polyatomic ion saying that we want 2 of the whole thing. Without that parenthesis there, that is not correct. So, give you a different example here. By the way, the 2 that you'll mess up more often is hydroxide and cyanide. These are a couple of polyatomic ions that people mess up all the time. One that you probably won't mess up as often would be nitrate. So let's do one for, let's say, strontium nitrate. For strontium nitrate, we're going to can you tell that I'm getting angry at my board yet, or my computer? It's not recognizing the pen very well. Strontium nitrate. Strontium is Sr. It has a +2 charge. And trust me, I am making 2's. It's just not seeing them. And nitrate is NO3. It has a -1 charge. So we're going to need 2 of these nitrates and 1 of the strontiums to balance it out. And what happens here is when you come in here to put this 2 here, people are going to see that 3 in the way, and they're going to realize, oh wait, that's kind of weird. I need to put a parenthesis in here to separate it. And that's why people don't really mess these up as often. Back up here with this example, you'll notice it would have been easy just to put a 2 here without any kind of parentheses and not realize that you'd made a mistake. So it's polyatomic ions. When you want more than one polyatomic ion, oh man, I can't even write on this thing. It's just seeing gibberish. I should say polyatomic ions. Polyatomic ions need parentheses. I'm just going to have fun with it now. Parentheses. Yeah. Oh, that actually worked better. Need parentheses. Polyatomic ions need parentheses if you double or triple or put a subscript on them. So that will be that. Oh, there's the bell. Oh, wait. Yes, the bell.